So for students trying to install Python on their own machine, we'll just have like a quick demo here, and I'll record this on YouTube anyways. But what we use in the class is Anaconda Python, which is free. And so if you go to the website here, the anaconda.com, you can download it. They have it for Windows, Linux, and Mac. And so you can download sort of the Python 3.7 version. And then once it downloads, you can just run it. So you should probably use the graphical installer unless you're very comfortable with command line stuff. What?
I thought we were using 2.7.
No, we're using 3. So all the stuff is in Python 3. Python 2.7 is, I think, soon not going to be supported anymore. So I think it's already end of life. And like Pandas and a lot of the libraries won't support Python 2.7 as of like next year. So you should try not to use Python 2.7, but actually with Anaconda, you can have multiple environments set up. And so some of them can be Python 2.7, some of them can be 3.6, some of them can be 3.7, and you just make new environments inside it. So once you download Anaconda, you can then run the installer. I don't know if I already have it. You run the installer and follow the instructions. And then what you do is you go to the course website. And you go view on GitHub. And you can just click this clone or download button to download the whole set of lectures and everything. And so there you get everything that's inside the course. And I think it's not very big, but I think it's around, ooh, I guess it's bigger than I thought. Okay, well, it's still fairly small, so if you have a reasonable internet connection, it should work. And so then if you have a terminal open, you can go to the course site, course directory, and then go to binder, and you have this file called environment.yml. And so basically what it has is it has all the packages we use in the course and all of the versions for them as well. And so then you can just do conda env. So you just type that line, which I'll add to the page for it, to create your own environment based on the course environment there. And so that will then install all of the packages and the right versions of them so that they run on your machine well. So if you use Colab or Kaggle for the exercises that will come up, you won't need to do this because they run on other machines. But if you want to have your laptop set up the same way as everything in the course is tested with, then you can run this. And unfortunately, I already have it installed, so the install doesn't work. But if we take off 2019, we can delete the old one and we can install it again to show that it actually works. But I'll add these instructions to the site so that you can follow it and a link to the video. It's not exactly the same on Windows as it is on Mac, but the commands you type in are the same. So now we can try it again. Now that we've sort of deleted the old one and we make the new one, and so you only need to do this once, and once you've done it, then everything's set up. And so what's nice about Conda versus sort of the standard Python with sort of pip installs is it makes sure that everything plays well together so that you don't end up with one really new version of one library that then doesn't work with a really old version of another library. And so this solving environment that it's doing right now is matching everything together so that you know that it works. And they also have pre-built libraries because libraries like OpenCV, which is really useful for like computer vision stuff and pre-processing, or ITK, which is then really useful for medical, are very difficult to compile yourself. So if you want to build them, you need to kind of know how C++ compilers work, and you need to have that all set up working. And if you use Conda, it just gets everything you need and sets it up for you, so you don't need to have all of those additional tools installed. But yeah, so that you can run that, and that